using Kubernetes, Docker, and OpenStack upstreaming. Before I start, I want to make sure everybody got the raffle ticket to win the Amazon Echo Dot, right? Okay, it's a great opportunity to win an Amazon Echo Dot, and since there are very less number of people, the odds to win the raffle is really great. My name is Vikram Hosakote. I'm a software engineer in Cisco, working on OpenStack cloud deployment, mainly on Kubernetes, Docker, and on Cisco UCS hardware. Today's talk is about how UCS is really a great platform to deploy cloud in containers. And at the end of the slide, I'm going to prove why we think UCS is the best platform to deploy cloud in containers. So let's dive right in. The agenda for the talk is I'm going to briefly discuss what is Cisco UCS, what is Docker, what is Kubernetes, what is OpenStack, and then I'm going to talk about a very popular, widely used upstream open source project called Call of Kubernetes, which deploys OpenStack clouds in Docker containers on Kubernetes. And then we'll talk about the role of Red Hat in our deployment. We'll also talk about OpenStack upstreaming. OpenStack is an open source project. We give back to the community. We give back code. We give back bug fixes, blueprints, features, test reports. We give back a lot back to the community as far as engineering is concerned, and then some Q&A as well. So to start, what's Cisco UCS? Cisco's unified computing system has been around since 2009. It's one of the most popular servers in the enterprise and data center market. We basically have a range of products, as we can see here. We have the B series blades that are put in a chassis. They're 1 RU, 1.5 RU. They're just inserted into a 5108 chassis. We have the C series rack server. They're like full-form rack servers. We also have the storage S series, which are used for storage use cases, for object storage, block storage, and also traditional RAID format as well. We have management software to manage all of this. We have a single pane of glass, a GUI software to manage all of this. And we have some modules, right? We have a Fabric interconnect, which abstracts all the servers into a single pane of glass. And we can use Fabric interconnect to abstract up to 64 UCS servers into a single pane of glass. And from a user's perspective, the user doesn't know that there are 64 servers. They're all accessible through the same GUI, the same API, the same CLI. So that does a very good job of abstracting, and also it reduces the port density on the top of rack switch, because that is to the south of top of rack switch. So if there are less number of ports in the top of rack switch, Fabric interconnect is a great device to connect more number of servers than the number of ports on the top of rack switch. We have the ISR Cisco E series, M2, M3, specifically for ISR servers. We have the adapters. We have network adapters, PCIe cards, GPUs, Cisco WICs, network modules, and we have the rack equipment, right? Rack and powering equipment. So this is the range of UCS hardware we have. All of them are hardware except the management part, which is the software to manage all of this. Diving into Docker. So Docker is a container technology. It's an open source container technology which has been very popular since a couple of years. Cisco has been playing with it as well. We have multiple projects that is using Docker, and basically it's a container technology which eliminates the need of a virtual machine, right? Everything is in the form of a container on a Docker daemon on the host, and every application or the service of the process is isolated in a container, and all the dependencies needed for the application are baked into the image of the container. So there's no problem like dependencies not found or things like if the application is going to work in a different environment, because it's always going to work wherever we deploy it, because it is deployed with all the applications together, with all the dependencies together with the application that are needed. And there's a Docker client as well. And there's another important part, the diagram, which is Docker registry, which is like a database of images that store the images. I mean the images of the Docker containers that are needed for the application. Kubernetes is a newer project than Docker. It's a layer on top of Docker for efficient management and monitoring. There are basically three parts to Kubernetes: the master and two worker nodes. And as you can see in the diagram, there are multiple components in each node. There's a kube proxy on the Docker nodes, and then there's an API server controller manager and scheduler, and an etcd database on the Kubernetes master. So the way we deploy it is we use tools to talk to Kubernetes master that will schedule our containers on the nodes. And this arrow here that spans across nodes is what networks the containers. So that technology is called Container Network Infrastructure, or CNI. And there are many plugins that network Docker containers in Kubernetes. There's Project Calico, there's Flannel, there's Weave, and we also have Cisco's open source project called Fungi that basically networks containers on top of multiple physical hosts. So from a user perspective, the user doesn't know if the containers are on 10 servers, 5 servers, 15 servers. The user just sees like a bunch of containers, like 25, 30 containers, and it's up to the CNI networking plugin to make sure that they're networked together. So a user can think two containers or peers or neighbors, and they can be on two separate physical servers in two different data centers, two different cities, countries, continents, as far as they're reachable through IP. And that's what CNI does. It hooks or networks two containers together in the cluster. And Kubernetes enables both local clustering, like rack level, data center level, and also global clustering using WAN and Internet. OpenStack is a very popular open source project to deploy a cloud in data center, basically for enterprise data center NFV applications. The main pillars that we can see are compute, network, and storage. All of them are virtual, of course. They have been abstracted to the user in the form of APIs and CLIs, and the hardware beneath is kind of transparent to the user. There's a nice dashboard GUI as well, and the hardware in our case, we are using Cisco's USys hardware, C-Series, B-Series. This is the project I want to spend some time about that deploys OpenStack Cloud in Docker containers on Kubernetes. This is a very popular project. I'm actually a core reviewer and a core developer of the OpenStack Cloud project. So basically, what it does is every service or every component of OpenStack is actually deployed in a container. So there's no need to worry that if the service works or not, because every service will be deployed along with its required dependencies inside containers. And that's the different layers that are needed for the architecture. We have the hardware, that's the bare metal. We have the RHEL operating system. We have the Docker daemon that takes care of containerization, and then we have the Kubernetes layer that does monitoring and management. And those are the components needed in the Kubernetes layer. At the top, we have the OpenStack Cloud that's exposed to the applications, right? And then on the side, we have more components. We have the Kubernetes master, where we give CLI requests or API requests to, and Kubernetes master will schedule OpenStack images on the node. And we also have a registry that has all the OpenStack Docker images in a version format. Depending on what version we want, the master pulls into the registry and deploys it on the node. And another important part on the master is the Ansible part that does the orchestration. There is Ansible. There's another component called call Ansible. That's Ansible version 4 Docker. We've kind of like Dockerized Ansible project. And we have another tool called GenConfig that generates default golden configs for all OpenStack services, and then we also have the golden configuration file that are needed to deploy. So that's the basic architecture. I know it has a lot of boxes, but that is trying to explain the entire architecture. And the applications are deployed on top inside each container. So this is just a summary of all the logos involved in the project. So Kala is an open source project. We have Ansible together with OpenStack, with Docker, with Kubernetes, and that's the logo for one of our CNI plugins called Project Calico that networks containers together in the cluster. So we have a lot of projects together to make a working OpenStack deployment on Kubernetes. Role of Red Hat, we use a lot of Red Hat products in our deployment. Most of them are RHEL products. We use the RHEL kernel, Red Hat Enterprise Linux kernel. We use the RHEL operating system. We use the RHEL OpenStack RPMs. We are at OSP 8 now. We are OSP 7, 8. And we are in the process of upgrading to the next release, the next available stable release. We are in Liberty with Tarkana. We use Docker images, and we also use RHEL's Atomic OS, which is a slim, lean operating system, just with minimum libraries that are needed for containers. It's unlike a traditional operating system. It doesn't have the entire operating system. It just has what's needed for the containers. And then we use RHEL updates and patches in our deployment. Outside of RHEL, we use Ceph for storage. We use Bugzilla for bug tracking. We also use service and support that's given by the Red Hat team, either in the form of email, phone, or on-site support as well. This is the last slide about OpenStack streaming. So basically, as I said, Cisco contributes back to the open source project. These are all the important links that are about the project, Call of Kubernetes, and it has all useful information to deploy, test, debug, scale an OpenStack cloud on Kubernetes and Docker containers. I am a core reviewer and the developer of the Call of Kubernetes project, and we are 4 of us here right in this conference, including myself. If you have any questions, we're more than happy to answer the questions or show some working configs or deployments. We have a bug tracking tool. We have a blueprint of the upcoming features in the pipeline. We also have stack libraries that shows different stats. As you can see, Red Hat is the top contributor. Red Hat contributes a lot to this project as well. So we consume the RPMs provided by Red Hat. And these are the top projects. As you can see, Collins will make in the top 10 projects. And outside of the top 10 projects, there are a lot of Collar projects like Kubernetes and Docker, Collar Docker as well. So basically, it's a mixture of multiple projects to get a working deployment on Kubernetes in version silos in the form of Docker containers. That's pretty much it. I'll be available on the other side of the booth for any questions. And as I said, I'm more than happy to answer any questions, show some configs, working deployments. We have all-in-one deployed to want to play in a single virtual machine. We need a minimum RAM of 8 gig, all-in-one VM. You can just deploy VM in VirtualBox, VMware Fusion, OpenStack, and then bring up an entire cloud in all-in-one VM. We have multi-node, we have bare metal, so different types of deployments as well. That's pretty much it. Any questions, anybody?